Right. So to answer that, we first have to say what we mean by the Big Bang Theory, because this phrase is meant in two very different contexts, right? We all know the universe is expanding, so if you run the clock backwards, if you run the film to the past, 14 billion years ago, it was in a hot, dense state, and we have something called the Big Bang model of cosmology, which is simply the statement that 14 billion years ago, the universe was in a hot, dense state. It expanded and cooled and went from being very smooth to relatively lumpy, which it is right now with all these stars and galaxies and so forth. That's the Big Bang model. It is true. There's no point in doubting the Big Bang model, okay? We don't let people up here on stage if they doubt that part of the Big Bang model. But if you take seriously general relativity and you say, well, what happened at the very beginning? What happens if... So we know exactly what the universe was doing 1 minute after the very beginning of the Big Bang, okay? From 1 minute after to 14 billion years after, we understand. That first minute is a little bit up for grabs. So classical general relativity, the theory that Einstein gave us for space and time, would say, according to Roger and Stephen Hawking, that at that moment, t equals 0 at the very beginning, there was a singularity. But there's also this thing called quantum mechanics, which gets in the way, which is not part of general relativity. So if you want to say the Big Bang event, the Big Bang moment, the beginning of everything, we don't know whether that is right or not. We have room as theoretical physicists and cosmologists to invent new scenarios and debate over which is right, which is wrong, and so that's where our disagreement comes in. I'm pretty agnostic, to be honest, about whether or not that moment, because it's a moment in time, the Big Bang, not a place in space. It's not an explosion in a pre-existing space. It's the beginning of everything. It's the moment before which there were no other moments. And that's the model, and the question is that model right? So I have two favorite theories, and neither one of them is Roger's favorite theory, so that gives us something to talk about. The one theory that I think is very... at least on the table, is plausible, is yes, that is the beginning of the universe, and it's because time and space themselves are not fundamental. That when you get deep into the guts of quantum mechanics, you realize that all the stuff around us, the tables, the chairs, space itself, time itself, are emergent, approximate phenomena. They're like talking about the air as a fluid with a temperature and a pressure rather than talking about the molecules. Maybe even time is just a good approximation, and it started 14 billion years ago. That's one possibility that I think is very plausible. The other, if time is truly fundamental, if time is real and there and inextricable from the fundamental equations, then I think it's very likely that the Big Bang was not the beginning in that case. But I also think that, as Roger has emphasized better than anyone, there's something very profound about the nature of time in our observable universe. Namely, that it has a direction, right? That the past is different from the future. And if we can get into this, I hope, the reason why the past is different from the future in your everyday life, the reason why you remember yesterday and not tomorrow, is ultimately because of what conditions were like at the Big Bang. That's what set up the arrow of time, and that's the fundamental mystery of cosmology. Why was it like that? So my favorite view of that is that there is a much larger universe that we don't see, that our little universe is a tiny little part of the whole picture, and the whole picture is actually symmetric, that there are people in our past who think that we are in their past, that time runs in the opposite direction for them as it does for us. This is not by any means set in stone, we don't know it for sure, but these are the kinds of scenarios that we're talking about as professional cosmologists to understand why the universe that we do live in looks the way it does.